All right, so 15.5 talks about factoring the difference of squares in perfect square trinomials. So we're first going to talk about perfect square trinomials, okay? This is just sort of going to be a coincidence in how we write our answer, okay? We're going to do the same thing that we've done before. So we're going to factor by grouping just like we've always done. So again, I'm going to think of that number there being a 1. So 1 times 16 is 16. I'm going to look for two numbers that multiply to 16, and in this case, add up to 8. It's going to be 4 and 4. Okay. So I'm going to go ahead and write it out. X squared plus 4x plus 4x plus 16. Okay, so I'll box my first two here. Out of x squared plus 4x, I can factor out an x, and I'm left with an x plus 4. I'll circle the second two. Out of a 4x plus 16, we can factor out the number 4, and we're left with an x plus 4. So there's my common factor, x plus 4. My other factor also happens to be x plus 4, so we can write this as x plus 4 squared. That's the only thing that's going to be different. I'm still using my process of finding or factoring by grouping. It just happens to be that I get the same factor twice, okay? So let me scroll down to the next problem. Again, my first step, let me multiply 4 times 25. That's going to leave me with 100. What two numbers multiply to 100? Oops, sorry. Let me go back up. What two numbers multiply to 100 and add up to 20? 10 and 10. Okay, so let's go ahead and write it out. 4x squared plus 10x plus 10x plus 25. So out of here I can factor out a 2x. I'm left with a 2x plus 5. Okay. Out of 10x plus 25, I can factor out the number 5. So 5 goes into 10 2 times. 5 goes into 25 5 times. Okay. There's my common factor. So I have 2x plus 5 and another 2x plus 5, which again just gives us 2x plus 5 squared. So really what I want to point out is this idea of perfect square trinomials, it's just a coincidence. It's just, wow, I happen to get the same factor twice, okay? The process and how I'm doing it, no different from how we did the others. Okay, so I'm going to show you guys a shortcut in how to factor the polynomials where the leading coefficient happens to be 1, okay? This only works when the number in front happens to be 1. So I'm still going to do the same thing. What's 1 times 81? It's still 81, right? Okay. This works only when the number in front of the x squared is a 1. The first step I'm going to do, I'm going to put an x here. I'm going to put an x here. Okay. And I want to make sure that I'm doing this right, so I'm going to say, okay, just like I was doing in grouping, what two numbers multiply to 81 and add up to a negative 18? Oh, I don't know, negative 9 and negative 9. I'm going to take those two numbers and I'm just going to write them in here, okay? Now, to make sure that I'm really doing this correctly, I can actually multiply everything out, see if I get the same answer, right? So x times x is going to leave me with an x squared. X times negative 9, a negative 9x, okay? Then I can go negative 9 times x, negative 9x. Negative 9 times a negative 9, positive 81. If you notice, if I combine those two, there's my minus 18, right? So that's just sort of a shortcut, but again, it only works when the number in front of your x squared is a 1, but that's really what my answer is, okay? So if my number in front of my x squared is a 1, it'll work. All right, let's try the same thing here for this one. So let's see, 1 times 169 is 169. I'm going to go ahead and use the shortcut again. Okay, x and x. So what two numbers multiply to 169? 169 is a perfect square. It's 13 and 13. If I make them both negative, if you notice, there's my negative 26. So minus 13 and minus 13. And again, I can just write it as x minus 13 squared, right? Now, for the next problem, I can't use a shortcut because the number in front of my a squared happens to be the number 9. Okay, so let's go ahead and multiply 9 times 16. Oh, let's see. Then I'm going to go ahead and get my calculator here. So, calculator, let's go 9 times 16 is 144. Okay, so I'm going to write that down right here, 144. What two numbers multiply to 144 and add up to 24? Well, I know that 144 is 12 squared, and 12 plus 12 is my 24, right? Okay, so now I have 9a squared plus 12a plus another 12a plus 16. So out of here I can factor out a 3a. We're left with 3a plus 4. Out of here I can factor out the number 4. Again, I'm still left with 3a plus 4. So now I have 3a plus 4 and another 3a plus 4, which again we can write as 3a plus 4 squared, right? 4, there we go. Good. So let's take a look at this next problem here. It's x to the third minus 10x squared plus 25x. First thing I notice, I can take out an x, right? I'm left with an x squared and a minus 10x and a plus 25. So my x is going to come down here. And I know there's going to be a square because I'm doing perfect square trinomials, right? So now if I'm factoring x squared minus 10x plus 25, I can go ahead and use my shortcut, right? 1 times 25 is 25. What two numbers multiply to 25 and add up to a negative 10? Negative 5 and negative 5, right? So that's going to be x minus 5 and x minus 5. And I'm going to put my x minus 5 squared right there. All right, the second part of 13.5 is the difference of squares, okay? And this is the only formula that you'll need to know for chapter 13, the difference of squares. And it says a squared minus b squared equals a minus b times a plus b. So the first thing we're going to do here, we're going to worry about how do I factor these types of problems. Okay, so the first step I'm going to do, I'm going to write two sets of parentheses. One is going to have a minus, one's going to have a plus, okay? So the first part here has a square, but over here it's just a and a, right? So I'm going to look at this part here, x squared. Well, that's got to be x and that's got to be x, because x times x would give me x squared. Second number is 49. So what number, when I square it, gives me 49? Or what's the square root of 49? 7 and 7. Now again, if I want to make sure that I did this right, I can go ahead and FOIL it out, make sure I'm getting the right answer. So x times x, x squared, x times 7, 7x, negative 7 times x, negative 7x, negative 7 and positive 7, negative 49. If you notice, those middle terms will cancel. And here's my final answer, right? So this really is my answer, but that was just sort of the check, right, to make sure it's actually working out. Okay, let's do the same thing here. Oops. Okay, one's going to be minus, one's going to be plus. Well, if that's a 4x squared, I need to put a 2x here and a 2x here. And if that's a 25, I need to put a 5 here and a 5 here. And we're done. Okay. Let's see, the next one here is 36 minus x squared. I want you to notice the order that it's written in. The number is written first, so I'm going to put my numbers first. 6 and 6. One is minus, one is plus. If that's an x squared, that's going to be an x, and that's going to be an x, okay? Now, what's real important about all these problems, this is what we call the difference of squares, right? And I want you to notice there's a minus in the middle. There's a minus in the middle. There's a minus in the middle. There was a minus in the middle, right? That's why it's called the difference of squares. When I look at this problem, the first thing I notice, there's a plus in the middle, okay? As tempting as it might be, we can't actually factor this one. This one is prime, okay? The formula, in order for it to work, has to have a minus in the middle. I can't do it otherwise, so that one there is prime. Okay? So let's take a look at some of these next problems. The first thing I want to do here is I want to see, is there anything I can factor out of both of them? Yeah, we can actually factor out a 9x squared out of both those pieces. And if I factor out a 9x squared, well, let's see, 9 goes into 81 9 times. And 9 goes into 36 4 times, okay? So just like we did before, I'm going to put my 9x squared right here. And now I'm going to worry about how would I factor 9x squared minus 4? Well, one's going to be a minus, one's going to be a plus. If that's a 9x squared, that needs to be a 3x, and that needs to be a 3x. And if that's a 4, that needs to be a 2, and that needs to be a 2. And then we're done. Okay? Good. So in this next problem here, again, I have 25x squared minus 144y squared. So I'm going to go ahead and do the same thing, set up my two parentheses. Since that's 25x squared, that needs to be a 5x, and that needs to be a 5x. One's going to be a minus, one's going to be a plus. Since that's 144y squared, one needs to be a 12y, and the other one is a positive 12y. Good. And so the last problem that I have here, 18r squared minus 8. Okay, again, the first thing I'm going to do, it looks like we can factor a 2 out of both of them, right? So that's 9r squared minus 4. Just like I did before, I'm going to write my 2 over here. Now I'm going to try to figure out how would I factor 9r squared minus 4. Well, if that's 9r squared, that needs to be a 3r, and that needs to be a 3r. And if this is a minus 4, that needs to be a minus 2, and that needs to be a plus 2, okay? So I'm hoping that you're finding 13.5 to be fairly easy section. It's just that one formula, and the other part, different perfect square trinomials, is just sort of a coincidence, like I said.